Hey, what's up, my seniors, my Invictus 2020 class? Don't think I forgot about you. You thought you got rid of me, but you can't. You simply can't. It's me, your favorite math teacher, and I know that it's kind of late, but I had to save the best for last, right? Alright guys, in all seriousness, all joking aside, I hope you guys are doing very well. Stay safe. I know this is all kind of new. Again, to me it's kind of awkward because I am talking to my phone and my neighbors are pretty close by and they must think I'm crazy. Just so you know, guys, I woke up at 7 in the morning and it is about 8 p.m. and I'm still working. So please bear with me, have patience and all this. I will try to upload these videos as quickly as I can. As long as the internet and my phone allow me to, I will. So there's a lot of things that are going on in, a lot of questions. So the first thing I'm going to tell you guys is that these are the emails in which you can reach me. The first one is jmarquez@fbspr.com, mr.j.marquez@gmail.com, and if you absolutely need to, my cell phone is 787-955-5749, although you guys, most of you guys have my cell phone anyway. So what are we going to do? Now, before you all start bullying me after the message that Mr. Alfaro posted in your chats, please have mercy on me. Don't hurt my feelings, all right? That message basically said that Monday, Wednesdays, and Fridays, I'm going to be uploading your math content, and then Tuesdays and Thursdays, I'm going to be uploading your physics. Now, for physics, the dynamic is going to be a little bit different than for math, because in physics, I'm going to look for more online resources. If I find a very good online resource for math, I will probably not record a video, but rather post the video and on your LMS tell you guys, look, this is the video that you need to look at for your math class. Now, this week, there was originally supposed to be scheduled a math quiz. But with this situation, that has been postponed. So what am I going to do? What I'm going to do is very simple. First of all, I'm going to review a couple of exercises that we did in class, a couple of examples, at least one or two. Then what I'm going to do is I'm going to assign some work. Now that work that I'm going to assign is going to serve as a review. And what you're going to do is you're going to email me that review, or email me those exercises, not that review, pardon. Email me those exercises, and what I'm going to do is I'm going to count those exercises as part of the quiz that you should have taken this week, so that way I can have your math grade ASAP, okay? That's what we're going to do. So at the end of this video, I'm going to give you those exercises real quick so you guys know what you need to do, and you can email them me to one of these addresses. Of course, this thing that says Camera Scanner is the app that I expect you guys to download if you want. The app is available for iOS, it's available for Android, and what it does is it takes a picture, and that picture, it converts it into a PDF file, so that way it's easier for you guys to share the email with me. Now, I've had other students from other classes ask me, when, or do I have to, or can I just take a picture from my phone? So if your phone is better than mine, and it probably is, and you want to flex that you have an iPhone or whatever, and your camera has pretty good resolution, then you don't necessarily have to download the app. I just prefer it because it's easier, it makes it more formal, more professional. But before I forget, before I start, congratulations to those of you that have gotten your university acceptances. I'm really proud of you guys. I wish you guys nothing but the best. And hopefully I will be able to celebrate with you guys soon once this whole situation comes down, maybe at your graduation, or back at the school. But now that all the pleasantries are done, what are we going to do and what am I going to do? Well, I'm going to give you guys two quick examples of what we're going to do. Or three quick examples of what we're going to do. One is where I'm going to explain to you guys what a linear function is, which is what we've been doing. Secondly, I am going to review one of the examples already done in class. And then thirdly, what I expect to do is give you guys the exercises that I want you to do. I want you to email them to me by Friday. The very latest that I can accept that is Saturday. And that's pushing it a little bit, and that's me being a little considerate that you do have other classes that you're doing, and I know that this situation kind of makes it awkward again. I'm talking to my phone, and my neighbors are hearing me. And if you hear the dogs barking, it's probably because like my high-pitched voice, drives the dogs crazy. But nonetheless, here we go, and here this is me. So here we go, guys. Your official pre-cal class. The topic: linear functions. Quiz review. Again, the quiz review is actually the exercises that you're going to send me, and I'm going to count that as part of your quiz grade. So here we go, the Invictus edition of pre-cal. All right, so I'm going to leave this here real quick, just so you guys can take a look at it one more time. I'm going to find the example real quick that we're going to do, and then hopefully we will start ASAP. As to like not lose the me looking at my book or whatever. So the first exercise that I am going to do is actually identifying linear functions, okay? So we're going to see two real quick examples, one story problem, and then basically I'm going to send you guys, remember you can email me, you can text me if you have any questions or any doubts. Also, midway through this week, we are going to be working on the online classroom. So now down to the nitty gritty, all right? So a linear function. What is a linear function? Just for record to remind most of you, linear function is written in the form a of x equals ax plus b, where a is the slope and b is the y-intercept. So to identify a linear function, remember that the x has to have an exponent of 1. If the exponent is 2 or any other number, then that means that this is not correct, all right? Or it's not a linear function, not that it's not correct. I'm sorry. It's late, so pardon any mistakes that I make. So the first thing we're going to do is identify linear functions. And when you identify a linear function, I give you an equation, okay? So that equation that I'm going to give you is this one. F of x equals 3 plus 1/3 x. So what we're going to do in f of x equals 3 plus 1/3 x is first identify if they look, or if the equation looks like this. This one is kind of like misshapen, it's kind of weird, and here I go looking at my pretty face. I'm going to wink at the camera one time. How you doing? All right, never mind. So what we're going to do is verify if this looks like this. So does this look like this? Well, it kind of does, but then again it doesn't. So what you can do is you can rearrange it, and you can turn that into f of x equals 1/3 x plus 3. Now, the signs don't change because I'm not moving the equation from one side to the other. All I'm doing is I'm just basically rearranging it. So if I look at it at this, I can see that the function here kind of looks like the standard form. So this is a linear function. So we say yes, right? It's a linear function. And that's the first exercise and the first thing you're going to do. And that's pretty simple, straightforward, to the point. I don't think there's much I need to do. Let me give you one more of these before I move on to graphing a linear function and then the story problem. Now in these story problems that I'm going to give you guys, basically it sums up the entire section. So that's why I'm going to give you like a couple of exercises. Those exercises need to be emailed to me and they need to be legible. Let me get to that real quick. They need to be legible. They need to be written down in a way that I can understand them. Ladies and gentlemen, make sure that your procedure is done because they are going to be counted as a quiz. So it's not where you just take the exercise and write them on a random piece of paper. If the exercises are not done in an orderly fashion, if they're not presentable, they will cost point deductions, right? So keep that into account. Now, let me give you one more example of identifying a linear function before I move on to the other two, okay? Then after that, the video will be over. I'll give you the details of what exercises you're going to be doing and when you're going to email them. Now, the exercises you're going to email to me And the video that I'm going to upload on Wednesday have nothing to do with it. What I'm going to upload on Wednesday is from an entirely new material for an entirely new section, which will be evaluated later on. This is for what you're going to hand in this week. So, going back to the exercise, the first thing you're going to do is identify a linear function. Identifying a linear function, you have f of x equals 3 plus 1/3 x. I'm going to compare this to the standard form of a linear equation. It doesn't look like it is, so what I do is I rearrange the numbers in 1/3 x plus 3, and then I realize that this does in fact look like this, so they are a linear function. Let me give you guys one more, and then we'll move on to the other example. And the other exercise that we have is f of x equals x plus 1 squared. So, f of x equals x plus 1 squared. Now, I know right off the bat that this does not look like this. They are not linear. The exponent is a 2, so this is a quadratic, or an example of a quadratic, so this is not a linear function. And that's pretty much it for that one, okay? So that's the first example. That's the first thing you're going to do. I don't think that there's much to do there. Once again, just compare this to this and let me know if it's a linear function or not. If it is a linear function, even after I rearrange them. Now, this is not the only one you probably have to rearrange. I might give you some other equations or functions in which you have to rearrange a little bit more to kind of get down to the equation and ultimately see if it is or it isn't. This one is kind of a given because if the exponent is 2, then automatically it's not a linear function, it's a quadratic, all right? So I'm going to give you 5 more seconds to look at that before I move on to the next example. Here I go again. Don't miss me for too long, although I know you're missing me. You might deny it, but you know you guys miss me. All right, here you go. I'm going to give you 5 more seconds. 1, 2, 3, 4, 5, and I'm back. You missed me? Of course you missed me. All right, I'm going to erase this real quick, guys, and then what I'm going to show you is drawing or graphing a linear function using the table of values. So I'm going to give you a linear function, a random linear function. We'll call this linear function f of x equals, oops, it's live. F of x equals 1/2 x plus 2. Okay, so I'm going to give you this linear function, and then you're going to construct a table of values, which you already know how to do, and then you're going to graph them. And after this, we're going to go down to your story problems, and then after that, I'm going to assign the exercises, and that's pretty much it for this. Then the video that I'm going to upload on Wednesday is for an entirely new section for something else. Tomorrow, I'm going to upload a video explaining what we're going to do for physics. Okay, so here we go. Alright, so table of values. I'm going to assign x values, and I'm going to assume that the values for x are going to be -2, 0, 2, and 4. Now the reason I chose these values is because since these numbers are divisible by 2, it's easier for me to do. Then I'm just going to basically plug in the numbers into the equation. Then I'm going to get my f of x, and then I'm going to plot the points. Very simple. So what you're going to do is, and here I go again, hopefully you see me, is plug in the 2f of x equals 1/2 times -2 plus 2. So 2 times -1, or basically 1/2 times any number, it's half of the number. So half of 2 is 1, so we're going to say f of x equals -1 plus 2, which equals 1. So the ordered pair that we have here is actually going to be -2, which was your x, and +1. Now we're going to do the same thing for 0. And we're going to say f of 0 equals 1/2 times 0 plus 2. 0 times any number is 0, so this would be 0 plus 2, which equals 2. And your ordered pair is 0 and 2. We're going to do the same thing with positive 2 and positive 4. So we're going to say f of 2 equals 1 half times 2 plus 2. Again, half of 2 is 1 because 1 half multiplied by any number is basically half of that. So half of 2 is 1. So you're going to say f of 2 equals, well actually you don't need to write f of 2. You guys understand what that means anyway. So basically, you're going to say 1 plus 2, which equals 3. So that means that the other ordered pair is 2 and 3. And last but not least, we have 4. So f of 4 equals 1 half plus 2. Or actually 1 half times 4 plus 2. Pardon the mistake. It is late. I've been up since like 7 in the morning. I haven't stopped since. 4 plus 2. So half of 4 is 2, and that would be 2 plus 2, which equals 4. So your last ordered pair is 4. Let me double check just to make sure I didn't make any mistakes. So 4 times 1 half is 2. 2 plus 2 is 4. And now I'm going to graph this, guys. I'm going to graph it. Very simple. And your first ordered pair is going to be negative 2 and positive 1. So 1, 2, 1, negative 2 and 1. 0 and 2 is going to be your other ordered pair. 2 and 3, so that'd be somewhere right about here. And 4 and 4, which is about here, more or less. And this is more or less linear function is supposed to look like. Remember, when I say to you guys in class, if you don't like the way I draw it, you guys do it nicer on your notebooks or your piece of paper, whatever you guys want to do. Anyway, this is basically example number 2. So once again, I'm going to leave that on the board real quick before I look for the third and final example. And then I assign the exercises that you need to do. Remember that we are going to be working on virtual classrooms sometime between Wednesday and Thursday, more or less. I believe the schedules have already been posted on your LMS. So keep that in mind very quick, all right? So I'm going to disappear for a couple of seconds. Well, not really. I'm just going to look for the next example, but you guys know, catch my drift, right? So take a look at that, and I'll be back in a couple of seconds with the final example, which is basically a story problem, one of the many that we've already done in class, all right? Alright, so pardon the awkward silence. I'm looking for your exercise real quick, and I believe I found it. Alright, so what I'm going to do is I am actually going to review one of your exercises before. And what I'm going to review is I'm going to review the exercise. Here I am again. I am going to review the exercise or the example that we did on page 193 of your textbook. Y'all remember my class time, right? No one stole it or no one took it away. You thought you get rid of this too. Alright, example number 4. I'm going to erase this now and then I am going to copy the example real quick. So, pardon me. Example number 4 says water is being pumped into a swimming pool. Give me 1 second, guys. Example 4, page 193. Water is being... And you can review this one in your notebooks because you have it in your notebooks. It's being pumped into a swimming pool. At the rate at the rate of 5 gallons per minute. Initially, the pool contained 200 gallons. So they're saying initially, $200 gallons. A, find the linear function V that models the volume of water in the pool. At any time t. Okay, so, and what I'm gonna do is I'm gonna answer these exercises little by little, and then we're gonna kind of work on that. So the first thing that they want us to do is they want us to write an equation. Remember that the standard form of a linear function is f of x equals ax plus b. Now, that f of x can be changed depending on what variables are given to me, all right? So depending on what variables are given to me is what I'm going to be doing, okay? So, it says find the linear function v that models the volume of water in the pool at any time t. So what they want you to do is actually first look at the variable. So f of x, in this case, is going to be changed. So I'm not going to be using f of x because f of x is kind of like my generic. And I don't want to use my generic, I want to use for volume. So that means that f of x is not going to be changed for v of t. And the reason it's going to be changed for v of t is because we're talking about volume and we're talking about time. Okay, so v of t is going to equal a of t plus b. So now I know that. I changed my h, my f for a v, and my x is for a t. V being volume and t being time. Now what I want to do is I want to see what numbers am I going to plug in for A and what numbers am I going to plug in for B. Now to do that, I go back to my original problem, and the problem says water is being pumped into a swimming pool at the rate of 5 gallons per minute. Initially, the pool contained 200 gallons. So 5 gallons per minute is actually a function of time because A of t. So we're going to change that A of t to 5 of t because it's saying 5 gallons per minute and minute is the time unit. So we're going to say V of t equals 5t. But I need to change the intercept or the other number, and that's going to be the 200 because that's going to be the number, the constant that I'm looking for. In this case, 200 because it's saying that the pool contained 200 gallons initially. So we're going to say f of 5, v of t equals 5t plus 200. And that would be the first problem. So again, I'm going to duck down real quick and we're going to kind of go back and forth. All right. So I am back and now we're going to write the second question. The second question says, and here I am again, the second question says, if the pool has a capacity of 600 gallons. Here I go again. how long does it take to completely fill the pool? How long does it take to completely fill the pool? So now this exercise, and here I go again, pardon me for a minute, is being more specific. Okay, so it's being more specific. Now it's saying how long is it going to take to fill up the pool if the pool has a capacity of 600 gallons. So, believe it or not, we have our equation. We're going to write this equation down. V of t equals 500, or not 500, excuse me, pardon my mistake, 5t plus 200. Now this exercise, or the second part of this exercise, is actually telling me or asking me, what am I going to do for this? Or what am I going to do real quick for this? Okay. Now, it says the pool has a capacity of 600 gallons. That means that the volume of the pool is 600 gallons, right? So that's what the 600 gallons actually represents in this case. So we're going to change that V of t to 600. And we have 5t and we have 200. Now, why do I change the V of t to 600? Because once again, V of t stands or represents volume. So in this case, the 600 is the volume. They're giving me the volume. So after that, what I'm going to do is I am simply going to solve the equation for t, because they're asking me if the pool has a capacity of 600 gallons, how long does it take to completely fill the pool? So what you're going to do after that is simply solve your equation by subtracting 200 in this case. This is going to cancel out. This is going to be 400 equals 5t. So you're going to divide by 5 on both sides. And this is like 7th grade math for you guys. And t is going to equal 80. So that means that about 80 minutes or so it would take the pool to fill up if every minute 5 gallons of water being poured into it. So guys, that's pretty much it. Now, just to avoid any confusion from what I might have said at the beginning of the video to what I'm going to say now, what you're going to do, or what I'm going to do next, and I'm going to give you a couple of seconds to take a look at that, is I am going to assign you some exercises from this section. This is section 2.6, or 2.5, excuse me, of your textbooks, linear functions. It was the last section that we discussed in class presentially. And what I'm going to do is, instead of you doing the exercises that you did, I'm going to assign you a different set of exercises. So let me recap that so there's no confusion. So if you're watching this video, you need to watch it to the very end, okay? I'm going to assign you some exercises from this section. There aren't going to be a whole lot of exercises because I know you have to keep up with your other classes. And what I'm going to do is, once I've assigned those exercises, I'm going to one more time write the emails that you guys can send them to me. And by the end of this week, by Friday, you're going to email me those exercises using the app that I gave you at the beginning of the class. Now, the video that I'm going to upload, hopefully on Wednesday, does not have to do with this quiz. It actually has to do with new material that we're going to start discussing for the rest of the week. And it is not going to be related to this. So here I go. I'm going to step off the camera real quick, and you guys are going to take a look at that while I assign the exercises and give you the pages. All right, guys? So I'll be back in a couple of seconds. Feel comfortable. Look at the quiz and or take a look at my pretty face. How you doing? All right, never mind. I'll be back. Okay, so the first set of exercises. All right, guys, I'm sorry. So I hope you all took a look at this. Now I'm going to erase it, and here we go. Oh. Yeah. You know, if you're making fun of me while you're watching this, please be kind. Don't hurt my feelings, okay? I mean, this is new to me. I feel weird. All right, guys. all joking aside, so the first set of exercises that you're going to work on is on page 195. And you are going to work on exercises 7 through 11. Now, you might be saying, but I already did those. Don't worry, you can do them again. It's okay. And after that, I want you guys to go to page 196. And on page 196, you guys are going to do problem number 20. Page 196, problem number 20. Now on page 96, what you're going to do is you're going to construct a table of values, you're going to graph the function, and then you're going to calculate the slope, because remember the rate of change is the same thing as the slope, and I know I already explained this in class, and you have some examples that you can look at. Now remember, when you're calculating the slope of a linear function, the formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And what you're going to do on that is take any two ordered pairs you want for this exercise and just do that, all right? When you're done with that, excuse me for 1 second, also on page 196, I want you to do the following story problems. Problem 39 and problem 41, okay? Page 196, problem 39, problem 41. Okay, so, you know what, and let me just be nice here. Let me just give you guys about, instead of 7 through 11, 7 through 10. So 7 through 10 on page 195, problem 20. On page 196, problem 39, problem 41. And on page 197, problem 45. Let me see something. 7, 8, 9, 10, 3, 4, 5, 6. 7 exercises, guys. Those 7 exercises. Now, these 3 are story problems. And you can look back at the examples because they're very similar, especially problem 39, 41, and 45 are very similar to the examples that I gave you guys in class for the day, so you should have exercises similar to that in your notebook. What you're going to do, right, is these story problems, you're going to write them down in your notebooks in a piece of paper very nicely, very legibly. You're going to do all the steps. If you guys have any questions, you can reach me via my email, jmarquez@r.com or mr.j.marquez@gmail.com or my phone number 787-955-5749. So guys, again, what you're going to do is you're going to work on these exercises. Page 195, 7 through 10. Page 196, problem 29, 30, and 41. And then page 197, problem 45. If you have any doubts, that's where you can reach me. When you're done with those exercises, you can email them to one of those 2 emails. And when you email them, identify yourselves, because I'm going to have a lot of other students from 10th and 11th grade also emailing me work. So make sure you write on the class subject, math work at 12th grade, so that I know, so that I know what we're doing. So guys, that's it. Officially, we are done with your very first Pre-Cal online class, Invictus 2020 edition, right? You know it. Anyway, guys, so you thought you'd get rid of me, but you didn't. I'm still here. My class is still here, especially for those of you that don't like math. This is the first online class. Yay! Anyway, guys, stay safe. Hope you and your families are doing well. I know I'm going to get bullied for this, but just like the message that you read said, I love you guys, all right? So take care. And this is your favorite math teacher signing off.